population proportion is what we are going to discuss next. So a population proportion would be confidence intervals in terms of proportions or percentages. So think about during an election year, we often see articles in the newspaper that state confidence intervals in terms of proportions or percentages. So if you take a look, for example, a poll for a particular candidate running for president might show that the candidate has 40% of the vote within 3 percentage points. So often the election polls are calculated with 95% confidence. So they'd be 95% confident that the true proportion of voters who favored the candidate would be between 0.37 and 0.43, or 37% and 43% of the vote. And it would be written or calculated, you can see here, as we did previously. So investors in the stock market are also interested in the true proportion of stocks that go up and down each week. So businesses that sell personal computers are interested in the proportion of households in the United States that own personal computers. Confidence intervals can be calculated for the true proportion of stocks that go up and down each week, and for the true proportion of households in the U.S. that own personal computers. So the procedure to find the confidence interval, the sample size, the error bound, and the confidence level for a proportion is similar to that for the population mean, but the formulas are different. So the first thing is, how do we know that we're dealing with a proportion problem? Well, the underlying distribution is a binomial distribution, and there's no mention of a mean or an average. Okay, if the random variable is a binomial random variable, then we look at a random variable that follows a binomial distribution, where n is the number of trials and p is the probability of success. So let's look at an example. So let's look at some examples with the population proportion. Suppose that a market research firm is hired to estimate the percent of adults living in a large city who have cell phones. 500 randomly selected adult residents in the city are surveyed to determine whether they have cell phones. Of the 500 people surveyed, 421 responded yes, that they own cell phones. Using a 95% confidence level, compute a confidence interval estimate for the true proportion of adult residents of the city who have cell phones. So notice that we are being asked to find a true proportion. There's no mean or average in here anywhere. So let's just state what information we have. We know that we have a sample size of 500. We know that we've got 421 that responded yes. We're going to have that be x, and the confidence level is 0.95. From here, we're going to use our calculator. You're going to go to Stat, over to Tests, and if you look, we are going to go down to, it's prop z int, there we go, A. So it's A, 1-prop z int. Hit enter. All right, our x value is 421, our n is 500, and the C level is 0.95. We want to calculate that. There we go. So we can estimate with 95% confidence that this is between 81% and let's say 87% of all adult residents in this city have cell phones. Let's take a look at the next one. Next problem. For our class project, a political science student at a large university wants to estimate the percent, keyword there, of students who are registered voters. He surveys 500 students, finds that 300 are registered voters. Compute a 90% interval for the true percent of students who are registered voters and interpret the confidence interval. So our x value here, which is the number of registered voters, is 300. Our sample size is 500, and the confidence level we are looking for is 90%. So in our calculators, we go to Stat, to Tests, we go down to A, which was prop Z integer. Our X value is 300, our N value is 500, and our confidence level is 90. So this means we can say with 90% confidence that between 56 and 64% of these students are registered voters.